Hi everyone, let's take a look at the following question. Calculate the acute angle at which the curves y equal to ln of x cubed and y equal to ln x intersect. Round the final answer to the nearest tenth. Now before I start, I am going to tell you, I'm going to redo this question twice. I'm going to do this in two different ways. And again, if you want to skip to method number 2, you can select the timer at the bottom in the description below. Here is method number 1. When I think about the angle between these two curves, what I'm really thinking is cosine theta equals to vector A dotted to vector B divided by the magnitudes of vector A times vector B. Now, when you think about this, this is really for two straight lines, right, or for two vectors. So if you think about vector A, vector B, always remember to connect them tail to tail. You're looking for the angle between them. And of course, we are looking for the acute angle right here. Now, if you go back to the given curves, y equal to ln x to the power 3 and ln x, these are not straight lines. And that is okay. The key is to find a tangent of each curve at the point of intersection. And with the two equations, you can use vectors to find the angle theta in between them. So now here's the first step. Find the point of intersection, the POI. Y equals to y. And again, let's make sure no one's left behind. On the left-hand side, this is going to be y, which is ln of x to the power 3. On the right, this is going to be y equal to ln of x. And again, if you're solving for x, the opposite of ln is you take the e to the power of, on the left-hand side, e to the power of ln of x cubed. On the right, it's going to be e to the power of ln x. Just like adding and subtracting, or multiplying and dividing, e and ln are opposite operators. So x to the power 3 equals to x. We're now going to solve for x, and you got to be very careful here. Even though you can bring everything to one side, and you can factor x to the front, which means in brackets it's going to be x squared minus 1. It doesn't mean all the answers are going to be useful. So in this first column, x is going to be 0. In this second column, x squared minus 1 equals to 0. Or if you isolate for x squared, that's going to be 1. X equals to plus or minus 1. So even though we have found x to be negative 1, x to be 0, x to be positive 1, the only answer that makes sense in this context is going to be x equal to 1. So again, these values are going to be omitted or rejected because if you look at the domain of the function, x can only be a positive number. And again, let's draw a diagram to illustrate this. So if I sketch a graph, remember the following. When I think about y equal to ln x, and again, that's the domain I'm referring to, y equal to ln x, x must be a positive number. It's going to look, roughly speaking, something like this. Again, there's a vertical asymptote located at x equal to 0. Now in a different color, if I graph y equal to ln of x to the power 3, which by the way, you can bring 3 to the front, this would give you a graph that looks, roughly speaking, something like this. Again, be mindful, there's also a vertical asymptote at x equal to 0. So the POI, point of intersection, is going to occur at 1, 0. This equals to the POI. So now what I'm going to do is divide this into two columns, and all I'm going to do is find the equation of the tangent for each case. So In the first case, I write down y equal to ln x to the power 3. Now again, I could rewrite this with the 3 at the front. Again, don't forget the exponent could be brought to the front as the leading coefficient. So when I find the derivative y prime, that's going to be 3 times 1 divided by x. Again, since we know x equals to 1, that is the x value for the POI, this means the corresponding slope is going to be m equal to y prime of 1, which means this equals to 3 divided by 1, or m is going to be 3. Now again, once you have the slope and the POI 1, 0, this goes back to grade 9 academic math. Y equals to mx plus b. You're going to plug in m and x and y. You're going to solve for b. So b equals to negative 3. Now the key here is to write it in standard form. Standard form. So even though you may be thinking y equals to 3x minus 3, what you really want to think about is 3x minus y minus 3 equal to 0. And we're going to come back to this. Now likewise in the second column, same idea. I'm starting with y equal to ln x. When I find a derivative, that's going to be 1 divided by x. Again, since we know the POI x value is going to be 1 for x equal to 1, the slope equals to y prime of 1. So in this case, the slope is going to be 1 divided by 1, which means m is going to be 1. Again, since you give the slope and the point, back to grade 9 academic math, y equal to mx plus b. This means I'm going to plug in m to be 1, x to be 1, y to be 0, and I'm solving for b. So b equals to negative 1. Again, the key is to express this in standard form. So instead of saying y equals to x minus 1, write down x minus y minus 1 equals to 0. Now, before we talk about the dot product and find the angle, let's update the graph. If I go back to the graph, here's the first update. Let's use a different color here. Let's say orange. So I'm thinking about y equal to 3x minus 3. So roughly speaking, it's going to look something like this. Y equal to 3x minus 3. And in a different color, here's the second tangent, which is going to be y equal to x minus 1. And again, the key is to find the acute angle. So acute angle theta is going to be right there. So it's no longer a curve problem. It's going to be two vectors, and we're going to use cosine theta equal to vector A dotted to vector B divided by the magnitudes of vector A times vector B to solve for angle theta. Let's go back. Again, cosine theta equals to, let's make this a little bit thicker for you. Let's try one more time. Cosine theta equals to vector A dotted into vector B divided by the magnitudes of vector A times vector B. Now, if you go back to the first column, vector A in this case is going to be 3, negative 1. Again, notice what I'm doing here. 3, negative 1. 3, negative 1. Likewise, if you look at vector B, that's going to be 1, negative 1. So one more time. If you trace back, this is going to be 1, negative 1. Just like that. Now, cosine theta equals to, again, it's going to be 3, negative 1, dotted into 1, negative 1, divided by the magnitude of vector A, which is basically the square root of the sum of the squares. Same thing here. Don't forget brackets. I can put brackets here as well. Now make sure your calculator is standing by in degree mode. We're going to work this out together, you and I, one team with one goal. When you take the dot product, 3 times 1 is going to be 3. -1 times -1 is going to be +1, divided by 3 squared is 9, plus -1 squared, that's going to be 1, so it's going to be the square root of 10, times 1 plus 1, and that's going to be 2, which means cosine theta equals to 4 divided by the square root of 20. Now again, take your calculator, turn it on, press clear. Make sure it is in degree mode. I'm going to do this with you here and now. Inverse cosine, 4 divided by the square root of 20. I see the following number in the display, 26.56505118, or it's going to be approximately 26.6 degrees. So again, method number 1, the final answer is going to be 26.6 degrees. Method number 2. Now I am going to redo the whole question except for the first part. It's going to be slightly faster. So if you're just watching method 2 right now, you might want to go back to method 1 and rewatch the first part just to catch up with the POI. So again, the first step in method number 2 is to find the point of intersection. Y equals to y. So ln of x cubed equals to ln of x. And because you can bring 3 to the front, this really implies that x equals to 1. And again, if you think about the coordinate, it's going to be exactly at 1, 0. So again, we're going to draw a graph. And your goal is to find the angle between y equal to ln x and, in a different color, y equal to ln of x to the power of 3. Now, here's the key concept behind this question. I am going to divide this into 2 different columns. In the first column, make the connection that tan of angle theta 1 equals to dy by dx. Likewise, if you think about angle theta 2 or tan theta 2, that's also going to be related to dy by dx. And again, the key concept goes as follows. First of all, if you think about y equal to ln of x cubed, this means the derivative dy by dx equals to 3 times 1 divided by x. And again, notice what I'm doing here. The 3 could be brought to the front. So I take the derivative of ln of x, which will give you 1 over x. So really, dy by dx equals to 3 divided by x. I'm going to put a box around this when I come back in a moment. Likewise, in the second column, when I think about dy by dx for y equal to ln of x, dy by dx in this case is going to be 1 divided by x. Now, here's the key. Think about the addition, subtraction formula for sine, cosine, and tan. And specifically, I'm thinking about tan of theta 1 minus theta 2, which we would denote in a moment as angle theta, which is the acute angle we're looking for. So if you go back to the formula, this equals to tan of theta 1 minus tan of theta 2 divided by 1 plus tan of theta 1 times tan of theta 2. Notice the absolute value brackets around. So if you think about this, order doesn't matter anymore. So if you define theta 1 with whatever you're thinking about versus theta 2, and you reverse the sequence, the final answer remains the same. That is the reason behind the absolute value. It makes it positive. Now, if we think about the x value of the POI, we're looking at x equal to 1. So for x equal to 1, tan theta equals to the absolute value of, and maybe I should write it here so you can see what I'm doing, tan theta equals to tan of theta 1 equals to 3. Now again, how do we get 3? Let's take a step back. Let's make sure no one's left behind. I'm basically taking x equal to 1, and I'll plug it back into here. So in this case, again, remember, we made the connection that dy by dx equals to tan of theta, or in this case, we call this tan theta 1. So tan theta 1, which is here, equals to 3 divided by 1, which is going to be 3. So likewise, this is also 3, just like that. Now, if you look at the second part, what about tan of theta 2? Again, tan of theta 2 equals to dy by dx, which we wrote down as 1 divided by x. So in this case, again, in a different color, tan of theta 2 means you plug in x to be 1. So 1 divided by 1 is going to be 1. So tan of theta 2 is going to be 1, which is here, and that's part of the formula. Now again, look what happens. Tan of theta equals to the absolute value of 3 minus 1, which is 2, divided by 1 plus 3, which is 4. This is basically the same as writing tan theta equals to 1 divided by 2. Now at this point, all you have to do is take your calculator, make sure you're in degree mode, and I'm going to do this with you. I'm going to write down the number I see in the display. We're going to round the final answer to the nearest tenth. So again, turn it on, press clear. Inverse 10 of 0.5. I see 26.565051118, or approximately 26.6 degrees. I hope this makes sense.